All right.
Ready?
Yep.
Okay. Now, what's going to happen a lot of times when you get to higher level math is you're going to know something about the ellipse, but you need the formula. Okay? This is what makes this the honors level course right here. All right? Is the idea of knowing some points and being able to work backwards to the equation. Now, I hate to tell you this, but it's fill in the blanks mathematics. It is fill in the blanks mathematics. As soon as you know you're going to write an equation for ellipse, you got 1, 2, 3, 4 blanks to fill in. So in that sense, it's not an essay question, really, it's a fill-in-the-blanks question. The questions y'all were doing before was like an essay question where you had to come up with all this information. Well, this is fill-in-the-blanks. Now, how I work them is I make me a little sketch. I make a little sketch. And I put 316 here. And that's a vertices. And 3, -10 down here. And then I know my foci are 3, 5. I'm going to put a V here. V here. Foci are 3, 5, which is just a little bit up. 3, 5, 3. Then from there, I can probably answer a few questions. But I take my information and I put it on a graph, and then I start asking myself questions, or I start thinking of information I can get from that. Well, does everybody agree that all of this was counted from the center? Find the center. And I'm going to tell you the easiest way to find the center. Use the midpoint formula. Add 5 and 1 and do what? Divide by 2. Yeah. 5 plus 1 divided by 2. Midpoint. All right, so we get 3. Didn't make them a very good problem. That's the center, right? Can you fill in 2 of the blanks over here?
Yes.
Yes, you may. -3, -3. Now, okay, you counted the longest up and down, right? Well, how far did you count from here to here? How far is that? 3 to 16? 13. Counted 13. That number, since that's up and down, is going to go under which one? It's going to go under the Y. And here's the problem. At this point, I may even draw some of the ellipse. We need this point right here. Because that would tell us how far we counted this way and how far we did what? Counted that. Is there a formula that talks about how far we counted to the vertex, or how far we counted to the foci, that involves the long count, the big count, the little count, and the distance, right? To the foci. Is that okay? Well, let me write it. Okay. Center to foci. Yeah, equals the big squared minus the little squared, right? The little count squared. Well, we know how far it is from the center to the focus. How far is it from the center to the focus? 2. Fill in the blanks. What you're going to do is you're going to look at the information you have, and you're going to pick out some formula that uses all the information you have to find what you don't have. And in this case, you know this amount. It's 2. You know the big count was what? 13. Is that okay? Minus the little count, which you don't know. Because that's what we want to know. And that's what makes this difficult, is students are not willing to look until they find a formula. All right? And I can't always tell you which formula they're going to use, because I had to look at the problem myself and go, okay, I got the formula for center to focus, I got the formula for eccentricity, I got the formula for lattice recti, but this one wasn't talking about eccentricity, it wasn't talking about lattice recti, so hey, I'm pretty good with this formula. Now, I'm going to square both sides. And I'm going to find out that I did not do a very good job of making a problem like I wanted. I'm going to get 165 is equal to the little distance squared. Well, I could write square root of 165 squared, because does everybody agree the little distance would be the square root of that? But that doesn't look pretty, does it? So I'm just going to write what? 165. If I write 165 there, what am I probably going to write here instead of 13 squared? 169, just to make it look pretty. And now, if you left it 13 squared, it's not wrong. That's just, you can leave it either way. And that's how you do it. Plot the points that you know, fill in the blanks that you can, and then, after you do that, see which formula will help you find the one you don't know. Because there's always probably going to be one that you what? Don't know. So far, so good. Okay, we're going to do another example. Not going to just do one or two of these. I'm going to do a couple of these. These are the big boys. Example 1. All right. Every once in a while, when I make these up on the board, I'll make up one that has more than one formula. You could actually, have two different ellipses that went through the points that I described. And I try not to do that too often, but it happens. All right. I've got somebody's like, yeah, if you look the problem up in the book, you got a better chance of working something that see, this is what they always say, Mr. Evans, you're never prepared when you get to school. Yeah, but I get prepared for later in the day. And plus, sometimes I go too fast. You know, to slow down. And I understand that. 9.1. Yeah, you're working out of Chapter 9 of a college textbook. That ought to tell you that you're kind of down the road. Right. Adds to the entertainment factor. A talent. Clean off the board. Oh, you can leave it running. It won't hurt them to have to watch all this.
Okay.
Those kids stay home every day. They're just in trouble. All right. This is out of the system book, which is where your assignments come from. And this is 9.1, number 42. And it says, because you don't have the book, you don't need it, so I'm going to call this up. Vertices. The vertices are 42. Well, that's too easy. Okay, the vertices are 5, comma, -1, and 1, comma, -1. And it tells you the minor axis is minor axis length is 2. Now, if the minor axis length is 2, how far did you really count both ways from the center?
4.
Be careful. It's too long, so you only counted what? 1 and 1. Is that okay?
Yeah.
1 and 1. That's all right. And what I should have done before I even asked that question is I should have gone over here and made me a little picture. Right? Let's do it. Someone says you can work these without the picture. You just go right ahead. Don't ask for my help. Okay. 1, -1. And that is a vertex. And then 5, -1. Now, if these are the vertexes, right, then it has to be longer left to right. Does everybody agree it's got to be longer left to right? Okay. It's going to have to be a center where? Right there. There's a center. I didn't do what I told y'all to do. I go over here and I make my fill in the blanks. And if I can find the center, that takes care of 2 blanks. What's the center, folks? 3, -1. Write it bigger so they can see it on that screen. That's the center right there. We add 1 and 5, divide by 2, 3, -1. And so we're instantly x minus 3. And we can put y minus -1 or y plus 1. I think without doing anything else, I can fill in one of these 2 numbers. Even without knowing the minor axis length, I can fill in a number. Which number can I fill in? I fill in the number that goes under the x. That's right, because that's your x direction. And how far did I count from 3 to 5? I counted how far? 2. So I can either put 2 squared there or put what? 4. Now, if my minor axis length is 2, that means I had to count 1 up and down. So I counted up 1. I'm going to write that in here. And I counted down 1. I counted up, down 1. So I'm just going to put 1 squared there. And there we go. Is that doable? Yeah. Fill in the blanks. Mathematics. Fill in the blanks, mathematics. See, I'm going to get to where I'm playing for the camera. I'm not going to make any political statements on the days that I'm up here teaching. Playing for the camera. 46. Let's go ahead and go hard. Y'all are good students. Let's go ahead and go hard. 46. Every one of these he has in the book gives you the vertices. I think that's too easy. Okay, vert. The vertices are -4, 6 and -14, 6. And then here's where he tries to mess with you. Eccentricity is 2 over 5. How many of you already know one of the formulas you're probably going to have to use to work this problem? What formula? That's right. Yeah, that's right, because you got to know the eccentricity formula. If you know the eccentricity formula, this is not going to be that bad. And you already know you're going to need it. And you just told me what it is, because y'all the one I had to write on the board for myself. And we're back to fill in the blanks, mathematics. Fill in the blanks. Okay, see what y'all can do first without me. Yeah, let's take a step, y'all do a little bit without me. I think I know what's the first thing I would find. I want y'all to do that, see what you get. See how you do. I'm just going to write a little bit of information on the board to see if it helps. Check your work. If you're having trouble finding the center, I'll put it on the board for you. If you're watching this from home tomorrow morning or this afternoon, this is a time for you to work it. Fast forward through this part. How many of you have 3 of the blanks filled in? You got 3 of them filled in? Yeah, 3. You got 4 filled in. That's the guy on the back row. I keep saying, man, I'm worried about him. I know it's 5 from here to here. All right. Miss, last name?
Flowers.
Miss Flowers. You told me just a second ago what the eccentricity formula is, right? What is it?
It's center to focus over
Center.
vertex.
Center to focus over center to vertex. Now, this one's kind of complicated, but if I know the focus, I can go ahead and find this, right? Okay, do you notice this is a 2-step process? Yeah, you got to find out, well, how far it is from the center to the focus, then work from there. Well, if the eccentricity is 2/5, then I know this is 5. So I know the center to the focus must be a value of 2. Okay, C2F. So center to focus equals 2. So I'm going to go ahead and put a 2 right there. Good. I see people looking at me like, Mr. Evans, you're lost. You don't put a 2 there. Yeah, don't put a 2 there. Because that's not, this number is how far it is from the center out to the ellipse. That's not it. Okay, so what formula did you use after this? You used the formula we've been using already, right? You did 2 equals square root of the big number squared minus the little number squared. Someone says, Mr. Evans, do we really have to write 5 squared? No, I'm just putting that on the board so people can follow what we're doing. And so we'll get 2 equals square root 25 minus little squared. 4 equals 25. And I don't know why I'm writing this because y'all know how to do this. And little equals let's just put little squared equals what? 21. Is that all right? The little number squared equals 21. Am I the only person who got that? Front row, did you get that?
I did not. I wrote 2 equals 5 minus x. I took the square root off.
Can't do that first.
Okay.
Can't do that first. And I'll show you why if you want me to, but no, you can't. You got to square everything first. You can't take the square root of each one separate.
Okay.
All right? Because imagine this all being in parentheses. So you can't just take the square root of each one separate.
Okay.
Okay? 21, so I'm going to write the number what? 21. All right. And that is what you'll see if you look at assignments tomorrow or this afternoon. This is going to be on your next assignment. I doubt anyone is finished with the graphing ones yet, but as you work through the graphing ones, and you probably finish those up tomorrow, then the next day you're going to do what? Start on these. Okay? Anytime you're home. Folks, if you're at home and you give me an hour on your virtual days, we're going to be okay. But you've got to give me an hour on your virtual days. And we'll do good. All right. Now, the next one I'm going to teach is a lot of algebra. That was a lot of thinking. This next one's a lot of algebra steps. And if you were able to work this one because you know it was multiple steps, I'm happy. All right. I am not going to try to make one of these up. This is an ellipse written in standard form. This is old school standard form for an ellipse. You will see this. I call it polynomial form because it's just kind of lined up nice like that. And it's handy for doing some of the algebra work that you'll do in a calculus class or trying to solve systems of equations. It's a lot easier to do it with this than it is the form for graphing. All right? I showed you the form that's best for graphing. Problem is, if you had this form and you needed a graph, you need to change it to the form that I showed you. And that's what I'm going to show you how to do. I don't have to graph anymore because once we change it, you'll know how to graph it. But how do you change this to the graphing form? So if you want to title this, some of y'all like to have little titles for your work. This is changing from standard to easy graph form. Or changing from old school standard to easy graph formula. And I'm going to show you how to do it. Now, how do I know it's an ellipse? Because later you're going to have hyperbolas and some other shapes. It's an ellipse because there's a plus sign between the x squared and the y squared term, and these two numbers are different. Okay? If those two numbers were the same with a plus sign, it's a circle. And if there was a minus sign there, it's not an ellipse at all. All right? Minus sign there, not an ellipse. Okay. First thing you're going to do is you're going to put your x's together. And I am not skipping a step. And I'm going to subtract the 36 because I want it out of the way. Someone says, oh, you can leave the 36 there. Yes, you can, and there is a way to do this, but I have to teach a lot of little bitty details, and we're just going to avoid those. We'll get the 36 out of the way, so we subtract it from both sides. Now, is everybody happy so far? If you're not happy, wave at me, because... All right, I'm going to factor out the 9. of these two and leave a blank. Leave a blank. Plus, we'll factor out the 4 from these two. Leave a blank. Put the negative 36 out there, don't forget it. All right. Everybody's got their blanks. Now, some of y'all I think are already using different color pens to take notes in here. Sometimes it helps because you can follow along later when you're at home. But here we go. I'm not going to tell you what this is called, and I'm not even going to tell you why I'm doing one step. You'll see it. But here's what you do. You always take half of that number, -4. You take half of that and you write it right down here. You take half of -4 and you write the -2. Don't skip doing that. You'll know in a few minutes why. Then you square the -2. And when you square -2, you get what? 4. You're going to put a +4 here. Now, there is a problem. Now, let's go through how we got there before we talk about the next step. I took half of the -4. -2. I squared it. I put a 4 there. I'm really not just adding 4 here because that 4 is being multiplied by what? 9. So I really added 36 to this side of the equation. What do I have to add to the other side of the equation? 36. Now, I'm supposed to put the plus 36 out there. If y'all don't mind, I'm just going to put it right here and I'll add them up in one column. A lot of students, this is where they miss it because they added 4 here, so they go over there and they add 4. Well, yeah, I can see you doing that because you're thinking, oh man, I added the 4. But remember, that 4 is being multiplied by how much? 9. Now, I'm going to take half of the -6. What's half of -6? -3. Please write that step down. I promise you it's going to be handy. Square -3, we're going to get what? +9. And then 4 times 9 is 36. And most of the time, you don't get the same number twice like that. Okay. I don't like the way that looks. Okay. So far, so good? So, now that I've done that, this will factor. That will factor. Remember factoring trinomials? Yeah, it factors. But I don't have to factor. I already know what it factors into. I already know what it factors into. That's the reason I wrote those down. If you will write those down, and you're using this method that I'm showing you, you don't have to sit there and try to factor that. It's always going to factor into what you wrote down when you were doing the last step. I just saved you having to do all the factoring. All right? Does anybody remember what this method is called? It's okay if you don't. I have trouble remembering what a lot of this stuff is called. This is called completing the square. What you're doing is you're making that a perfect square so that it's easy to factor.